Welcome to the Chemistry e-learning. Today, we're going to learn a new topic, metals and the reactivity series. But what does this got to do with the Titanic? Well, we all know Jack and Rose went down with the Titanic. But we know that many other things gone down as well. These are some of the things that have gone down. Sure enough, the ship on the left submerged. Together with it are valuables like those on the right. Now, what do you think these items are made of? You're right. The bowl is made of iron, while the recovered items are made of gold and silver. Do you see any difference in the states of this item? You're right again. The iron bowl is much more corroded compared to the gold and silver artifacts. Why is this so? To understand this, we need to know about the phenomena called rusting or corrosion. Oxygen and water is needed for corrosion, and it is a redox reaction. How do we know that it is a redox reaction? Work out your oxidation states and convince yourself that it's a redox reaction. You're right again. Iron's oxidation state increases from 0 in iron to +3 in rust, while oxygen's oxidation state decreases from 0 in its elemental state to -2 in rust. So, this is a redox reaction. Alternatively, we could write the half equation and we will see that iron lost 3 electrons to form iron 3+ during corrosion. Since silver or gold corrode less readily than iron, we can infer that silver or gold lose their electron less readily. Since corrosion is a reaction, and iron corrodes more than silver or gold, we can say that iron is a more reactive metal compared to silver or gold. Now, given the following descriptions, arrange the metals in decreasing order of reactivity. Here's the answer. Hope you have gotten it right. The more reactive metal reacts more vigorously and with milder reagents like water. The most unreactive metals doesn't even react with acid. Now, it is through this empirical observation, that is, observing through experimentation, that scientists come up with the reactivity series. You would need to know which metal reacts with cold water, steam, and acid. To help you memorize the reactivity series, here's the mnemonics. Please send cat, monkey, and zebra in 3 large hard cages, make sure got padlock. Enjoy the animals. Now, let us revise some reactions of metal. Reactive metals will react with water spontaneously to give hydrogen and metal hydroxide. Such metals include calcium and potassium. The not so reactive ones will only react with steam to form metal oxide and hydrogen. Most metals will react with acid to form dissolved and hydrogen gas. What do you notice about these 3 reactions? You're right. Hydrogen gas is produced. You would have noticed that these reactions are all displacement reactions, and hydrogen has been displaced from the acid or water by the metals. What can we conclude about these metals? Now, here's a revision of the displacement reaction. In general, displacement reactions will only occur if A is more reactive than B. Using your knowledge of the reactivity series, predict if the following reactions will occur. You are right. Zinc will displace iron because zinc is more reactive than iron. However, hydrogen will not displace calcium as hydrogen is lower in the reactivity series as compared to calcium. Aluminium will displace iron because iron is lower than aluminium. That's great. Now, we've almost come to the end of the e-learning. Here's a summary of what you need to know. Scientists have ranked the metals based on their reactivity, and this ranking is called the reactivity series. The metal higher on the reactivity series will displace the metal lower on the reactivity series from its compound. Now, take out your lab assignment and watch the next 3 videos.